Hello, good morning. My name is Hassan Ali. I'm the Senior Product Manager at Baker Hughes Systems and Technology team. Today, we are going to look into addressing one of the challenges identified by the industry, which is how can new project execution and technology makes marginal time of fields and projects for prolonging the life of installations more profitable. And we believe we have a solution to offer here, which we call a multi-well flow base, a radical low cost and a fast track template solutions. So templates are very well known in the Norwegian shelf, has been used for decades now. They've been standardized over several years of design experience, fabrication experience. But however optimized they are, they still look big and heavy. And the idea here is, can we challenge it slightly? Can we challenge the specifications? Can we make something more compact than what they are? So on the screen is a brief example of the evolution of the design with a 10 years timeline. The one on the left hand side is a 10-year-old template, highly complex functionality, bespoke design, resulting in a 26 by 22 meter size, 650 tons of weight. Going from there towards standardization, NCS economy, sharing of economy, where we are just now. It is optimized. We've taken 24% reduction in the footprint, 15% reduction in the size. Hey, but still, it's 23 by 19 meters, 580 tons of the system weight. System weight refers to the weight of the manifold, the template, the trees, and the choke bridges module in a typical four-slot configuration. So overall, from a system perspective, it is still heavy. What can we do? One of the solution is that we have created is what we call a multi-well flow-based system. With the new system, we've taken the footprint reduction of 35% to something like 19 by 15 meters, and the weight has dramatically reduced by 40% to 350 tons. Wow! So how we are able to do it? I'll give you a brief intro or insights into this. As we all know, the templates are driven by, like any product, driven by what are the key functional requirements, what are the industry requirements. So the fundamental requirements in a template are there needs to be independently installed the manifold, the trees, the choke bridge modules. All of these individual modules needs to be commingle together on the seabed, and they will ability to reconnect and disconnect. What that gives, it gives complexity in terms of design, the tolerances required to make sure that this happens and this is tested, and the complexity in associated cost, and not at least the overall size and weight. You're doubling up on steel, doubling up on connections, and with the use of multi-bore connection system, there is a lot of fabrication that happens on the small bore tubing to ensure everything gets together. So these are the key requirements. And then when we challenge some of these, the result what you see is what we call a multi-well flow-based system. Essentially, this is, if you imagine a tree on a flow base and you scale it upwards to make it a four-well flow base, and the manifold is essentially fixed on the template itself, the pipework of the manifold. We know from a fact that manifold are a reliable product. There is such a rare event of any retrievable of a manifold. Hence, we believe that it is technically feasible to have a fixed manifold on the template. When it comes to the tree to manifold connection is essentially a vertical land out and a mantle connector. There is no separate choke bridge module. So we have removed essentially the manifold and the choke bridge from the template, and the result is what you see on the screen. When it comes to the distribution system, another inherent part of the template, we have we have changed the solution slightly to, instead of using a multi-bore tines, we have a pre-laid hydraulic and electric flying leads, which are made by ROV on the seabed. What this essentially does is it simplifies the construction process. It uses predefined and existing flying lead product line, and it enables a cleaner layout and a simpler layout from a fabrication perspective. The flow base is based on mud mat. Essentially, we have the possibility to pile the foundation in case the conductors are not in place. It's a single lift installation, which means when you install the flow base, you actually install the whole thing with the manifold. There is no separate manifold to come later. So it does save significant amount of installation time and cost. So this is primarily designed for the diver range, so something in the range of 100 to 150 meters, essentially because of the use of flange connection for diver made up. It can be scaled up to a medium motor space with using diver-less tines. It's fully feasible. What are the benefits? So the key benefits are this is 35% reduction in the footprint, 230 tons of less steel on the seabed, which translates to 460 tons of CO2 emission reductions, which is a dramatic reduction. It's a Totex light solution. It's a lower on capex, lower on installation, lower on operations. It's a simplified system which accelerates time to your first oil. As mentioned, no separate manifold, no separate choke bridges, the flying leaves are separately laid out, so in case of any contingency, it's possible to recover the flying leaves and reinstall it. Overall, it's a shorter testing period because you have fewer modules to interface with each other. When it comes to the valves, these are flanged to allow flexibility during fabrication, something which is field proven in the industry as well. So the total system, we believe, when standardized, can be delivered within 12 to 15 months. And this is the complete system, including the manifold, which is a dramatic shift. And we, as I also mentioned, installation benefits because you have less structures, less modules, and there is a reduced installation time of operations. So all sounds great, but where we are from the physicality of this. So we are doing projects where five of these is being fabricated as we speak, and then they are on schedule to be installed in the second half of the summer of next year. And there is another flow base which will be delivered toward the end of next year. So we have demonstrated with this product a lower cost, size, and weight. It's a fit for purpose. It meets the CO2 reduction targets that everybody's has the responsibility. And what we see is also a need for more and more operators to open up for such type of a different solution, functionally equivalent, fit for purpose. And at the end, also to mention that the flow base is patented by Baker Hughes. And I'll close with a comment that I would like to thank my colleague Steiner Heston and the team in Baker Hughes involved in the development and realization of the flow-based solution. It's an alternative to a traditional ITS. We believe we make a big step with this product. Feel free to reach out for if you have more questions or clarifications. Thank you for your time.